So this is 8.2, basic graphs of rational functions. The first two problems are the basic graphs. It's the only thing I'm going to ask you how to graph is something easy like these. Number two being the harder of the two. This thing should probably be written better as a fraction, but apparently I was lazy with the equation editor. So I'm going to focus on this. That is a right 4 and a down 1. So I'm just going to drop the x-axis 1 unit, and I'm going to shift the y-axis right 4. And the nice thing is I pretty much learned the horizontal and vertical asymptote. The horizontal asymptote is at y equals -1. The vertical asymptote is at x equals 4. I have also learned for this particular function the domain and the range. The domain on this thing is from -infinity to 4, union with 4 to infinity, because I will not cross that dashed line. The range, I will rise from -infinity to -1. And once I cross that -1, I will rise to infinity. So there's all that crap. Mom is a rational function. Normally contains -1, 1. Sorry, wrong mom. This is mom. Mom normally contains -1, -1, and +1, +1. Now there's something funky about this one. It's this negative symbol. So negative mom is going to look a little bit different. She would look like this, because I reflect over the x-axis. So she contains -1, 1. And what else does she contain? She contains 1, -1. And then there's this 3. That's actually really easy to fix. So negative mom, -3 moms. You just multiply the y value by 3. She's going to contain -1, 3, and 1, -3. That's really all there is to it. Not that bad. But she's going to have -1, 3, and 1, -3. Oh, I forgot about the shifting. Yeah. Oops. I went right forward, didn't I? Last thing was the shifts. I'm sorry, I'm wiped out. All I'm going to do, because I'm really, really tired, is I'm going to focus on this. I'm going to go to the right 1 and down 1, but instead of going down 1, I'm going to go down 3. I'm just going to redraw that rough graph. I'm going to focus on going to my new origin instead of going back 1 and up 1. I'm still going to go back 1, but I'm going to go up 3. You're probably like, Milbrath, that can't be right. You didn't actually plug in numbers and plot points. It is right. It's a very good look of that graph. I might have this a little too steep, this a little too shallow, but it should be what it looks like, that, or I just need to restudy some of the stuff. 3 divided by parentheses x minus 4 minus 1. Zoom 6. See? It's what it looks like. Ta-da! All right, 4 is an analyzing of a graph. These are a little rough. You do have a horizontal asymptote. It's okay if you cross a horizontal asymptote. She's right there. Horizontal asymptote is at y equals 0. You've got 2 vertical asymptotes. There's one right here, and there's another one right here. So that's fine. Looks like one of them's at -2 and one of them's at +1. I had to infer a little bit there. But one of them's at -2 and one of them's at 1. The zeros, there's one at -3 and there's one at 2. At -3, that's a touch. The multiplicity is 2. And there's another one at 2. The multiplicity is 1 because it's crossing the x-axis. So that's fine. Domain is from -infinity to -2. Union with -2 to 1. Union with 1 to infinity. The range is everything because we actually have intersections here. Even though we have a horizontal asymptote at y=0, it's crossing the x-axis, and you can see it covers everything from here to positive infinity, from something higher than that guy to negative infinity. It's negative infinity to positive infinity. All right, now I get to write my equation. We'll call her f of x. She's going to have the letter a in the numerator, which we'll have to figure out. So the 0 was at x equals -3, and the multiplicity was 2, x plus 3 squared. There was a 0 at 2, multiplicity was 1, x minus 1. You have to go back and look through your notes here, but I see this guy right here. Sorry, I see this and this. So I'm looking at that one asymptote, and it's doing this, and then it's doing that. That is an odd multiplicity. And that was created by, looks to me like x equals -2. So x plus 2 is at least to the first power. Then I have what's going on here. I'm shooting up to positive infinity on both sides. This is an even multiplicity. That was created by x equals 1. X minus 1 happens at least twice. Something is wrong here. That's supposed to be -2, isn't it? Sorry. I'm probably going to stop after this. I'm too tired to be doing this right now. I gave you a point on this one, 0.18. That gives me an x and a y. So I'm going to plug it in. 18 equals a times x is 0. Nice. 3 squared, -2. 0, 2, -1 squared. See what happens? 3 squared is 9 times -2 is -18. So a times -18. Down low, we end up with a 2. And we get that 18 equals -9a, so the a value is -2. So put a -2 there, and she's done. And that is the equation of number 4. And I'm going to stop. I wish I had time to take a nap, but I don't.